get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, wherever you are in the world. I'm Johnny Rickard. I'm going to be the host today of the Ask an OpenShift Admin live stream. I'm joined today with Reese Oxenham. I'll let him introduce himself in just a second, but yeah, just wanted to say, hope that you're having a great Red Hat day. We got a lot of things going on in the Red Hat world since last night, so things are a little bit crazy. But yeah, so just to get it kicked off, if you're not familiar with the Office Hours series, the Ask an OpenShift Admin live stream is part of the Red Hat Office Hours series. So like any other Office Hours, if you have any questions, we're here to answer them and hopefully get any outstanding things that you may have about OpenShift and just Kubernetes in general, let us know and we'll try and get them knocked out for you. So real quick, let's go over the top of mind topics. So I'll save the biggest one for last, but next week on July 21st at 10 a.m. Eastern, the What's New in OpenShift 4.11 stream is going to be out to talk about what's coming out in the 4.11 release of OpenShift. So make sure that you tune in for that to see what features are going to be there and get some more insights about like what we're going to be putting out there for you. The next big thing was that a project Kyverno, which is a policy generator for Kubernetes, it moved to the incubator status on under the CNCF umbrella. This is going to be an awesome project. So if you're familiar with Gatekeeper, it's very similar to Gatekeeper, but instead of you having to learn, like, I think it's Opal or something like that, it's using the native tooling from Kubernetes, so you don't really have to learn anything else about the policy generator except for just generating the policies that you need to keep your cluster secure. And then the last one is the big news that came out last night about Matt Hicks is stepping up as the CEO of Red Hat. So there's an announcement made yesterday on our website. I don't know if Stephanie, if you have the link in our chat, if you could post it for those that aren't familiar. But Paul is going to be stepping over to the chairman role, and Matt Hicks is going to be the CEO. I think it's going to be pretty awesome. He's part of the OpenShift OG team. So, I think that having that experience and then being a developer for a long time, I think that, it's going to be good for Red Hat. So it'll be interesting to see how things move forward. So, all right. So with all that craziness out of the way, let's talk about, Edge and Datacenter, and let's introduce our guest, Reese. So Reese, you want to tell us a little bit about yourself?
Yeah, absolutely. Thank you so much for having me back. So my name is Reese Oxenham. I'm a director in the customer field engagement team. So we work very closely with some of Red Hat's largest customers worldwide, trying to make sure that they are successful. But we also try and take a lot of the lessons learned, understanding some of the gaps, the features, the bugs, the issues that our customers are running into, and try and help our product teams make better decisions. How do they prioritize features and how do we build them out? And my team, we work on a lot of the core platform side of things. So everything from getting servers up and running, deployment, infrastructure, storage, networking, virtualization. And we primarily do all of those things with OpenShift and Kubernetes. We got a lot of sort of experience around some of the other technologies in the hybrid platforms portfolio. So historically, we've done a lot of work with OpenStack, for example. And I'm delighted to be here to talk about, as we've called this, from going from the data center right out to the edge, because my team does a lot of work in the edge space as well, understanding how our customers are trying to leverage some of the new edge type of topologies.
Yeah, awesome. And in our pre-show, we were talking about this a little bit. There's a lot of tooling that's coming out that Red Hat's developing and putting out there that are really built around this use case of edge to the data center, back to from data center to edge and back, right? And so, I think for a lot of me and Andrew specifically, and by the way, Andrew's in training. So I did forget to mention that he's in training. He's out, taking a day off, trying to get his learn on.
I'm sorry, Christian. You have to make do with me.
Yeah, suck it up, Christian. You'll be okay. But yeah, so like when we talk about the edge, right? I think a big question that comes up all the time is like, what is edge? So like, can you give like what's your explanation of like what edge computing is?
Yeah, sure. So when I think of the edge, what we're really talking about is shifting data, applications, and the processing of that data and the location of those applications right quite close to where the actual subscriber or the user of that data is. So for decades, organizations, they've been deploying infrastructure in centralized data centers, right? And those data centers, they've been distributed, for resiliency and things like that, but they've still been quote unquote centralized somewhere, be that at colos or within the organizations themselves, right? But what we're really talking about is pushing that data much closer to the subscriber where they might want to get access to it. Now, I've used this example quite a few times. When you look at an example like content distribution, right? You want to almost, rather than relying on a bunch of centralized data centers and having the cost of the bandwidth and the latency associated to it to get that data out to the subscriber, what if you were able to push that content much, much closer and have tens, hundreds, thousands of individual distribution centers much, much closer to that subscriber? So the cost of that data transfer and the latency of accessing that data is much, much smaller. It makes your network much, much more efficient, and makes it much easier to get access to that data. And we also think about some more sort of extreme examples. You could think of, well, what if I want to put infrastructure on a cargo ship or a train? Or when you look at maybe like a military example, putting infrastructure in a soldier, right? As in they would have a wearable or some sorts. And so we at Red Hat and for our software platforms, we really have to think about, well, how do we have to change or adapt our solutions to fit into all of these wide variety of new use cases and designs?
Yeah, I actually love that about the soldier, because I thought about it like a level higher. I've actually worked on a couple of projects where we're putting like Kubernetes on airplanes, and we're talking about putting on military vehicles and stuff like that when it was over in NAPS.
Yeah,
but yeah, to
exactly.
take it a level further and put it on a soldier, that's pretty interesting to think about. It's dope. I can't wait to see something like that. That's gonna be awesome.
Yeah, absolutely. And we try and adapt our software, and we always have done, right, to maximize its reach. There's no one size fits all solution for our software, right? And so edge, and like many other verticals or markets, I mean, telco is a perfect one historically, right? It's pushed us into new areas we've really had to explore, quite extreme requirements and expectations, right? And edge is just kind of almost to a certain extent an extension of the requirements for telco. I can see you smirking. Yeah,
I'm laughing at Christian.
No. I thought Christian would be being difficult already. So we've really had to think about some really extreme expectations and requirements, and trying to build in some of that resiliency and the flexibility in our software to accommodate it. Christian jokes, right? But there may well be a situation where there will be a server or a piece of hardware running in a remote environment that our customers expect that it has the resilience, requires as close as possible to zero human intervention, that it has all of the automation it requires to rebuild itself in the event of a failed upgrade. It has no reliance on some core infrastructure for pretty much anything, and it can be as autonomous and standalone as possible. And so we are having to build software platforms or modify our existing software platforms to cope with those environments. And you likely saw the announcement that we had this week with ABB, talking about some of the work we're doing with them, and some of the requirements they have from an industrial perspective. And it's projects like that give birth to projects like Microshift. And that's the absolute smallest possible footprint of an OpenShift or Kubernetes like implementation that we're working on. So lots of flexibility.
Yeah, it's awesome. I think like I was, this morning's been back-to-back calls nonstop, but like one of the calls earlier was that just kind of talking about like Red Hat is great at making products, right? Like we've done a really great job of doing that.
Sure.
But then a lot of the conversation around solutioning is where it's like, okay, well then there's probably some room there. And I feel like this is where we're starting to like fit that mold right now. We're starting to solution we're starting to put solutions out there for people. Like, hey, here's how we've solved this problem. Here's how you can go do this. And like, even with my team, what we're doing with the validated patterns is we're saying, hey, here's the art of the reality now. It's not this like whiteboarded, art of the possible. It's like, okay, we're actually putting, foot to the pavement right now, and we're actually getting stuff done. And here's how you can actually take the same thing and do it. That's pretty good.
Yeah, no, absolutely. Standardization, consistency, but also flexibility, is front and center with pretty much everything we do, right? As I said, we recognize there's no one size fits all, but we also have to try and provide, as you say, solutions to customers that have a wide variety of expectations.
Yeah, awesome. So real quick before we get started, or get too far into it, make sure you like and subscribe on YouTube, guys. So if you're on YouTube or if you're on Twitch, make sure that you like the channel, so that way we can keep this content coming to you. Try and get Reese on here more often to come talk about some more of the awesome stuff he's working on. So Reese, I know you're here to talk about some, just we kind of brought you in on like this like big umbrella conversation, so.
Yeah, I didn't quite know what to prepare for. So let's see what sort of questions we get in the chat when we start talking a bit more about some of the technologies we've got in our portfolio.
Yeah, right on. So do you want to go ahead and start kicking off some of your demos or some of the things that you want to talk about?
Yeah, absolutely. So, let me have a think about maybe sharing or showing Microshift at a really sort of simplistic level. And I've already alluded to Microshift being this super super thin, lightweight implementation of OpenShift, right? And you can kind of think of it just as a single binary with very minimal hardware expectations, targeting multiple architectures that you can pretty much run on anything. It can be as small as possible. And I'm just going to very briefly share my screen, and I hope this works. You'll let me know if it doesn't.
Yep, it does. If you could just make it a little bit bigger.
I'm not sure I can because I'm in presentation mode.
Okay, well then, it should be fine. Are your slides public?
Well, yes and no. So this comes from a public presentation that a colleague of mine did at the OpenShift Commons last week. So I think we're absolutely fine in sharing it. So maybe we can put the link somewhere, or maybe I can just zoom in here and show you what I'm kind of control alt. Yeah, I'm not really sure how this is really going to work.
Awesome.
That's not working at all.
This reminds me of this tweet that I saw the other day, where this guy was like, "Whoever does your demos in presentation mode or not in viewer mode like this, like who hurt you?" It's funny as hell. I'm sorry. Just triggered like that.
No worries at all. So when we think about the various different edge topologies that we can essentially support with OpenShift, right? If we think about it right the way from the bottom, we have supported for a number of different releases this concept of a 3-node cluster. So you can think of this as a converged master and worker configuration. So 3 nodes. So you have your resiliency inside of the cluster. It can work, autonomously at the, kind of the edge site, and you can converge storage on there as well. So for all intents and purposes, you can throw this out there at your edge site and it'll work and be absolutely fine. This is more of a kind of a full implementation of OpenShift. So it has everything you can possibly need and want just in 3 individual servers, right? If we take that up again, we have something called single node OpenShift. Again, single node OpenShift has been available for quite some time, and it's that same full fat OpenShift implementation just on one machine. So the challenge with that, of course, is, well, how do you make that highly available? Well, it's not really designed to be highly available within a single machine, but for situations where you have perhaps the smallest physical footprint, and you just want to have a single server at that site, then single node OpenShift gives you that full OpenShift experience in one single machine. We also have the concept of remote worker nodes. So this again is pushing infrastructure to the edge, but still being reliant on a sort of a centralized data center. So you still have that management capability from a centralized data center, but you're just pushing the worker nodes directly out to the edge. And then for very small footprint, we have a couple of different options. We got Red Hat Enterprise Linux for Edge, and we have something called Microshift. And Microshift is what I want to briefly demonstrate to you. So I'm just going to move that out of the way, and I'm going to pull this over. So Microshift, as I mentioned, it is simply a container image or a binary that has a very small, lightweight version of OpenShift included in it. So all I have here, this is just a Fedora machine. So if I do that, you can just see this is a Fedora 36 virtual machine. And if I list the containers that are running on this, you'll see that it is literally just a Microshift instance. So everything is contained within this container image. And when it starts up, it just runs a Microshift binary. So if I was to do a podman logs for this, you just literally you see all of the output of the Kubernetes implementation inside of Microshift just there, just as if it was any other process on the system. Now, that basically means standing up Microshift is really as simple as pulling the container image and essentially starting it up. And of course, we provide documentation on how you can do this. Now, we of course, because this is OpenShift, we have all of the OpenShift command line tooling. So we can do get nodes, and we have that single machine. Right, we can get all of the pods on the machine, and you'll see this is a very stripped down version of OpenShift. There's no web console for it. There's no operators. It's very, very simple and lightweight because it's designed to simply run inside of those environments where you want a minimal configuration that requires very little CPU memory and things like that, and just allows you to get started really, really quickly. Now, just because this is this is a lightweight version of OpenShift, I can still deploy and create pods and do deployments. There's also aspects for doing things like virtualization inside of these environments. I can deploy Metal LB, so if I want to have access to some of these virtual machines, makes it super easy to do. So if I've already deployed a couple of applications here. So if I was to do get service on my test one, you'll see that I've got a couple of different pods here. The one I'm using to expose Nginx with load balancer, and I've actually exposed this over Metal LB. And this is my IP address. Again, it's just on a libvirt network. So I should be able to just hit up this, and I can. So that's just going over Metal LB to my Microshift instance. And again, because it's OpenShift, I can get my roots, and I've created a root there. Hello, Microshift.rdioxnum.com, and I should also be able to navigate to this, which I can. So there's a few different ways of getting access to these clusters. Just because it's Microshift doesn't mean you're really hindered from a workload or a networking perspective. So I'm going to stop sharing. I want to see if there's any questions on anything that I was doing.
So we do have one question. One was, can I run Microshift on Windows?
As far as I'm aware, no, you can't.
Okay.
So I believe it's shipped as a container image today. There may be you can build the binary separate, I believe, but no, I don't think you could run it on Windows.
Okay, awesome. And then Christian was asking about the if there was the fix for the router change to keep it from being .local, and then he was saying that it looks like he just sent a link saying it looks like it's still open. So
yeah, so for exposing networking routes, we typically use MDNS. So essentially we can broadcast available a route. So you could be on that network and it'll essentially resolve those. Very similar to how on your phone you want to listen to Spotify on your Sonos or whatever. You click want to choose my non-Bluetooth, but it's a network speaker, and it shows up in the list. That's using MDNS, right? We do a very similar thing for exposing routes inside of the network. And by default, Christian, you're absolutely right. It does have a .local domain by default. But you'll see that when I created my network, my route, I specified dash hostname, and I can kind of override the route that the router ingress is having to identify. And so long as my external DNS understands that has to go to my Microshift instance, it resolves just like any other application.
All right, awesome. And then Dwayne was asking, so Dwayne's doing some training, like some self-study, trying to get us learned on to OpenShift and Microshift. So he's asking, so now I need to plan on Microshift for his home lab, assuming Ansible and SDN tasks are linked to Microshift. The first part of that is Ansible, no, but the SDN, is it using OVN, or is it using like the OpenShift SDN?
I believe it's using like simple flannel based network. Yeah, so I don't think there's, looking on this machine, I don't think there's OVS. I certainly don't think there's OVN. It's just a really, we try to really compress everything to the smallest possible footprint that it can take up, and that's why, of course, it has some limitations, but it's still that consistent. From an OpenShift perspective, it's very familiar to use, just in a really lightweight package.
Exactly. That's awesome. And so, and this has parity with like K3s, right? Like this would be like a okay.
Yeah, absolutely. So yeah, container image, very minimal configuration, spins up very, very quickly, very, very simply. Yeah.
Okay, awesome. And then Adele just asked, what's the difference between Microshift and OpenShift Local, which I was corrected last week. OpenShift Local is the new branded name for CRC. So
so CRC is kind of a portable or sort of portable is probably the best word. A portable way of standing up an OpenShift instance on your local machine. And so we essentially download a QCOW2 image. We turn it on, and we do some ways of getting into that cluster via some of the local networking. But that's a full blown OpenShift instance. It takes up a fair amount of resources because it's still a full blown OpenShift instance. Microshift, we're talking about a few megabytes. It's tiny, and it's designed to be put on, something as, I don't want to use the word, use the term Raspberry Pi, but I'm sure it could probably run there. We're talking about things like NVIDIA Jetsons, right? Really small, yet capable devices, somewhat the size of a Raspberry Pi, that will run right at an edge location, where you just need a familiar Kubernetes API that you could interact with, and has that simple mechanism for updating, has the sort of the notion of being able to, have rapid recovery of the platform in failed upgrades and things like that. So capable, but also limited in its capabilities, because you wouldn't necessarily want to run your development pipeline there. You're not gonna need to have the operator hub running there, or for it to do any additional tasks, other than literally run the applications it needs to at that site.
Yeah, exactly. And the one thing you're saying it is the familiar API, right? So it's like for all you sports ball fans out there, it's like you practice how you play. So like when you are at the far edge with this, Pi or Jetson or whatever, and you're running, almost at K3s, but if you're running Microshift, right? Like that interaction at the far edge is going to be the exact same interaction that you'd have, minus the operators that you would have back in your data center with your full-on cluster.
Yeah, exactly.
So then Dwayne asked another question. In terms of a lot, I assume Fedora IoT works, or is there a list of hardware like Raspberry Pis? Is there a hardware compatibility list for the Microshift?
I don't know whether we have anything built, but I've used Fedora IoT just because, for two reasons. First of all, it's super easy just to set up Fedora IoT. Mm-hmm. But secondly, because it somewhat mimics how we expect customers will deploy Microshift. So Fedora IoT uses RPM OS tree, right? So it's a largely immutable file system, has built-in recovery. So let's say, for example, we upgrade the base OS. If it detects that there's a failure in the machine coming back up, it'll reboot and it'll revert back to the previous one. Whereas, a typical other operating system wouldn't do that, and it'd expect some kind of user intervention. So it's an operating system like Fedora IoT or RHEL for Edge that we would expect customers will deploy Microshift onto. But Microshift is just a container image, right? So you could run it on pretty much anywhere. Which gives it great portability, great flexibility, and the hardware requirements are, they're minute.
All right, awesome. And then one question that came in was, how can zero trust practices exist on Microshift or in Microshift use?
Maybe Dwayne can elaborate on what he really means there.
Yeah. So Dwayne, if you have an example of what you're looking at, let us know. So with Microshift, like we'd seen before in a previous stream, right? Like we had some of the Microshift team on, that you can do some of this, like the management of the cluster, right, through ACM and stuff like that. So is that the goal, to move all of the management of the Microshift cluster, or to manage all of your Microshift clusters at the edge and beyond through ACM? Or is there going to be another tool?
Yeah, so we're looking at sort of a fleet management solution, right? Because if you've got lots of these devices out there, you obviously need to think about patch management, right? How do I build out not just the underlying operating system, but also how do I respin the Kubernetes, Kubernetes image, or essentially the Microshift image? How you do that? So we are absolutely looking at fleet management tooling, and how you actually look after that. But yeah, a lot of it is, well, ultimately it's still an OpenShift or a Kubernetes implementation. And so when you're looking at distributing your applications, you can still essentially hook into it from an ACM perspective, an open cluster management perspective. So provisioning applications to it is just like provisioning anything to a quote unquote normal OpenShift implementation. So again, it's about consistency, right? It's the same, but just in a very small package.
Gotcha. So Fleet Manager, it's Fleet Manager, like, is that the rebranding of something, or is that like is that another project?
That is a good question. I am not totally sure on all of the details around the fleet management stuff, but it is something that is actually being worked on.
Okay, awesome. Yeah, because I think when Andrew and I were looking at this, right, we just noticed there's all of these things that are coming out here, and they seem similar, but then when you start digging in, like they all have a purpose, right? Like we talked about the central infrastructure manager, and then we have ACM, and then we have fleet manager, and then there's some, I don't know if I should say this out loud. I feel like I'll probably get in trouble for saying some of these, but there's some of these other projects that are coming out, like where it's kind of like these single node Kubernetes, not quite Microshift, but maybe like a bit bigger than Microshift, but not as big as a CRC or I'm sorry, OpenShift local. You know what I mean? So like there's just all these like things that are coming out here to manage the edge and the far edge and stuff like that. So it's interesting. Yeah. It's an interesting space because it's growing like crazy.
It is, and as you said a number of times, right? There's no one size fits all. We can't just say, okay, every customer that wants to do Edge has to do single node OpenShift, right? Because single node OpenShift is still a full fat OpenShift implementation, right? You boot it up, it still has the same requirements and expectations as any other OpenShift node in any other cluster type, right? So you still have to have a fairly comprehensive machine at each of the edge sites. Well, what if the edge site is, we want to provision to Jetsons, or we want to, as we're going back to that example, the soldier has to carry this infrastructure. It has to be, really, really low power, and have all of these, expectations around self-recovery, fault tolerance, and things like that we have to try and address. And that's where solutions like Microshift comes in.
Yeah, 100%. I think it's awesome. I really do. So like when I was on a project where we, like I said, we put Kubernetes on a plane, and I think that had Microshift was very early. Like it's very early, and it's like public knowledge, or awareness of it within Red Hat, I think. And I think if it had been ready, this would have been the perfect solution, because we had OpenShift back in the data center. We wanted to keep that same workflow and pipeline and tooling all the way out to the plane. And it would have been amazing to put it out there. And I've been on a couple projects where we've been like this close to where it would have just been awesome, but it's just timing loss, So
I hear you. Well, talking about putting things on planes, if you'll want to go and have a look at the Endurance project, there is actually an instance of Microshift that went out into space.
Oh, I did see that. Yes.
Yeah.
Yes.
So, plane, we're a little bit higher than a typical plane might fly. So that's actually really cool. So Microshift has made it into orbit. So that's
right.
It's pretty awesome. And again,
right.
Pushing boundaries for where our software has to be able to operate, I think is really cool.
Yeah, I totally agree. So Dwayne asks if there's a plan for Microshift container to be a UBI or certified image. I believe it's already built on UBI, but
I think it is absolutely built on UBI. Should be absolutely compatible for
that. Do you know? And I don't. This may not be public knowledge yet, but do you know when the transition from project to product, or whatever that's labeled is going to be?
No, I don't think we can talk about anything like that.
Okay,
just
cool.
yet.
All right, awesome. So then the other part is Christian is he thinks it's pretty awesome that you're drinking out of a whiskey glass, drinking water out of a whiskey glass. So
yeah, everyone asks that. I mean, I think this is a somewhat normal. Maybe it's not normal. I don't know. Maybe it's a European thing, but it seems like a normal glass to me. But everyone seems to call it a whiskey glass. I don't know.
Well, you're getting a bunch of street cred for drinking water out of a whiskey glass with us. So
there we go.
So we briefly talked about like the central infrastructure manager.
Yeah.
Did you want to talk about that and show some of that off?
Yeah, absolutely. So there's so we've been working on a number of different things, as you say, right? So single node OpenShift, Microshift, Hypershift, which is something we can perhaps come on to later down the line. But also looking at next generation ways of deploying infrastructure on premise. And, we touch on the concept of things like zero touch provisioning and zero touch provisioning for factory workflows. So I did want to briefly demonstrate some of the ways that we can do things like zero touch provisioning through the sort of central infrastructure manager, which is a component as part of ACM or MCE for, a bit more of a lighter weight option for customers who don't necessarily need all of the additional capabilities of ACM. And its ability to drive some of those zero-touch provisioning type workflows. So what do we mean by zero-touch provisioning? Well, I, as an administrator, want to have the ability to define my nodes and through a few clicks, defining, okay, this is what I want my cluster to look like. These are all the credentials you need. It go away and deploy OpenShift, right? So it's talking about, from a true zero-touch provisioning perspective, powering the machine on, attaching a virtual media, an ISO of virtual media, the cluster bootstrapping itself. I don't have to worry about external requirements for things like DHCP. I don't have to worry about external load balancers or anything. It is a programmatic way of pretty much deploying and controlling the entire end-to-end model. So vodka on the rocks, indeed. No, not indeed. So let me share my screen again, and I'll just show you some of the workflow you can do here. Share screen, my entire screen, and I hope that this is going to be big enough. I'm not sure I can make it much bigger without it kind of distorting the UI. So I just have an ACM, so Advanced Cluster Manager for Kubernetes environment here. And we have this concept called infrastructure environments. And
hang on just a second, Reese. We need to get Stephanie to share the screen for you.
I apologize.
You're all good. So just so everybody knows, Stephanie's kind of straddling two meetings right now. So we've got her super extended. Thank you, Stephanie.
All right, we good to go?
Yep, good to go.
Awesome. Okay, so I'll define an infrastructure environment, and this kind of roughly allows me to kind of group cluster. Don't want to use the word cluster. Allows me to group a set of hosts together, and that sort of grouping could be, well, it's that data center, or it's this particular region, and then I can then go ahead and build out clusters from it. So I'll go ahead and say create infrastructure environment. I'm going to give it a name, and I'm going to call this SNO2, because I'm going to deploy a single node OpenShift environment within this cluster. So I'm going to say location here is Cardiff, which is where I am. Sorry, I think I missed this. Network type only use DHCP or static, so you can define all of your networking interface information statically. I just realized I'm gonna have to stop sharing my screen to put my pull secret in here. Otherwise, this is funny actually. I actually managed to leak my pull secret in another stream. I think the first time that I did this, and then I had to go through all of the motions of revoking it, because it would allow anyone to deploy a cluster as me. So I'll quickly run through these options, then I'll eventually click next. So I put my pull secret in there, which, as I'm sure everyone that's watching essentially knows, that this is a way of kind of authenticating myself, so I can pull container images and integrates within the Red Hat console at redhat.com, and attaches everything through the cluster manager and things like that. So I'll just quickly stop sharing. I'll pull this information in, and I'll reshare after I've hit the create button. So bear with me.
Yep, and trust me, we've all done it. I think both Andrew and I have both gone through the Mother May I have a new pull secret.
Yeah, absolutely. And I really don't want to go doing that again. It wants my secure shell key as well. So I'll pop that in there, and I should be good to go. And
Yes, me too, Christian.
All right, just a quick look at the chat. You've exposed your AWS secrets. Ooh, yeah, that's and they're much smaller strings, right? So you could really quickly grab those and provision something probably before the stream has even finished. So yeah, all right. I'll go ahead and reshare my screen now that I've pulled them in. And Steph, I apologize for that. You let me know when we're good to go again.
I will. So I'm just sending Stephanie a chat real quick.
No worries.
Hey, Stephanie, if you're listening, could you enable the screen share again? And I think the cool thing too is that, like, looking at it through the ACM menu and stuff like that, like everything that you're going through, it looks very similar to the automated install or the assisted installer interface as well, right? So the whole consistency story that you've been talking about, right? I think it's good.
Absolutely, and that's actually a really good segue. So a lot of the experiences and lessons learned that we've got from the assisted installer, and actually the workflow and the wizard, when the screen sharing comes back on, you kind of see a lot of familiarity. Building up and defining your cluster in a very similar way to the assisted installer, it makes things so much more simple, right? And our customers really like that approach. And so yeah, being able to drive it in exactly the same way, same consistent way is absolutely key.
Yeah, awesome. All right, so we might be in a little bit of limbo here, waiting on the screen share.
No worries.
How long does it take generally for because I know with the assistant installer, it probably takes, 15 minutes, maybe 20. Is it about the same?
So there are so many variables, unfortunately, right? If you're doing real bare metal, then some of these machines can take 10 minutes just to get to be ready. And there's a couple of reboots involved during some of those steps. So via AI or via the zero touch provisioning model, typically with some bare metal machines, it can take an hour, right? There's also, where are the container images being served from? Is it on a local registry, or are you pulling from the internet? What sort of bandwidth do you have? Is there a proxy involved? There's quite a lot of variables, so I can't say, okay, it's going to take about 20 minutes. But I would say about an hour might be typical on real metal. I'm going to use a VM in this example. There's only about 20 minutes left of the stream anyway, so we'll probably be able to kick it off. But I don't think we're going to be around to see the cluster actually finish. But yeah.
Yeah.
Long story short, it depends.
Yeah. No. I kind of teed that up there a little bit because that question, it comes up a lot. Is it going to make things faster? Is it like, what's the timeline? But it really does. It's variable as it's as variable can be. There's
exactly
all kinds of things.
Exactly. But I think what it likely does really help with is historically we've offered our bare metal IPI workflow, right? Which is, okay, I download the OpenShift installer, I define all of my nodes inside of my install config, I run it, and it goes out there and provisions all, many of my nodes. The way that we do it with zero-touch provisioning is slightly different in that we don't require a separate bootstrap machine for the initial stage. We actually turn one of the nodes into the temporary bootstrap machine, and we do what's called a bootstrap in place. So that actually simplifies the deployment somewhat. And with the mechanism I'm showing you here, it's all UI, right? Of course, you can define it via the API, and there's you can define pretty much everything I'm doing here in YAML files. And if you want to drive some of this, I know Christian, you'll love to hear this. But if you want to do a lot of this through through GitOps, then you absolutely can. I'm just kind of showing it from a demo perspective via that UI.
Yeah, 100%. And just so you know, the screen share is back up. So
brilliant.
Yep,
Okay,
we're ready to go.
All right. So I've now created this SNO2, and it's just a single node OpenShift environment. I've called it SNO2 purely because I'm going to do a single node OpenShift deployment, and we've already got stuff registered in DNS for this. So it's looking good, but there's no hosts. And again, for those of you that are familiar with the assisted installer UI, this is probably looking very familiar. So we can go in here and we can say, well, I want to add a host. And hey presto, we have a discovery ISO ready for us. So if we wanted to attach these images directly to our machines and boot them up, we could do it very much like an assisted installer perspective. However, if I also wanted to do more of a zero-touch model, I can go straight in. I can say, well, hey, you've got access to the BMCs, which just like ILO, DRAC, xClarity, and things like that. You can go directly to these machines. And in here, I've got, let me get rid of that. I've got just some of these credentials stored. So I'm going to put my host name in there, my management controller address in here, and it certainly doesn't matter if we leak these. These are all VMs. My MAC address that it wants. The username, I think, is Red Hat, and a super secret password. And is that everything I need? Yeah, I think it is, because we selected DHCP. So I'll go ahead and I'll create that. And it's going through a number of different stages. It's going to start doing what we call an inspection. So it's going to attempt to provision this machine, and just like the assisted installer would do, it's going to fill out some of this information. So it says bare metal host. It's not really, but it's going to go away and it's going to fill out all of this. It's going to get information about memory and my disk layout, networking configuration, basically get it ready to work. Now, this is very good from a we use Redfish and virtual media, so we get a little bit of a sort of standardized way of deploying various different bare metal platforms. So pretty much anything that supports Redfish, we can do deployments with. So this makes it really straightforward. We can power these machines on. We can attach the ISO directly. You see that I didn't have to go into the console of this machine to attach this ISO. It did this, and it did this very quickly again. This is a virtual machine. It's not a real bare metal machine. That's why I did it so quickly. Mm-hmm. But we're able to, really go ahead and use this.
So awesome.
So we've now created this infrastructure environment. We've got this node registered, and what I can then go in and do is I can go in and create a cluster, and we use this on-premise, which is where the sort of the SIM comes in. We'll go and select this. We can go in here and do node 2 cluster set. We can choose it if we want to. Base domain, so this has to match. So my cluster name and my base domain has to match. I'm going to say I want install single node OpenShift because I've only got one, and of course it gives us this typical limitation. There's not going to be HA, and we can't currently add additional nodes. This is a slightly older environment here, so it doesn't know about OpenShift 4.10, but it shouldn't matter for the purposes of our demo. It's got my pull secret down there. Hopefully it'll let me get rid of around that. Yeah, okay, good to go. and this is reviewing it. Now we get to choose our hosts. One host matching, which I suspect is our node that we just did. There's my VM. Okay, so that's the one we just made before. So it's going to go ahead and it's going to. So we got here. It's finally filled out some more information about our virtual machine. KVM, 32 gigs of memory. Got more information about the available disks. We got a number of disks here because we want to do some. Perhaps we want to do some OpenShift data foundation storage, and it's just got one NIC that's on our corporate network. I have to select a subnet. I can use advanced networking if I want to. I can go in here and I can say I want to override the default CIDRs. It's going to want my secure shell key, which I can.
That's pretty awesome. Like that. So I think we've talked about the infrastructure manager before, about how you just kind of you pull these machines in there, just kind of like they're just ready and waiting. I think that is so awesome.
Yeah, it is, and it's very familiar again to those of you that have used the assisted installer. Driving this is super simple, and as you say, you've got this pool of hardware. So the administrator can go ahead and define all of the hardware that's within a given infrastructure environment, right? So again, that infrastructure environment could be a data center, it could be a region. It's down to organizations to define. But then I, as a maybe an infrastructure or a cluster administrator, I need a new cluster, and it has to be on bare metal for lots of different reasons. I have these various different pools available to me. I selected single node and it just looked for an available host, and we just used the one that we just created, right? But you could be pulling from a pool of tens, hundreds of available machines. And so, this is just going to simply go ahead and it's going to go and provision. And for those of you that are familiar with the assisted installer, you will simply see it's already shown me the cluster API address, console URL, and shortly we'll have kubeconfig, kubeadmin password available to us. And remember, this is being driven through ACM, right? So when this comes up, it's just another cluster that's already available through ACM. So all of your typical policies you could apply, you can manage it just like any other cluster.
That is, so Christian made a comment in the chat that it's really cool. I agree completely. This is really awesome. And I saw you kind of clicking through it a little bit ago, and we're going to bring some of the Ansible team and ACM team on to talk about like integrating with AAP and Ansible and stuff like that. So then a lot of your post config you can do this is going to be amazing. I can't wait to see this like in like a full on.
Yeah, I probably clicked through that bit a little bit quick in the interest of time, but yeah, absolutely. Post deployment hooks into AAP. Yeah, you can absolutely do those things. One of the things we've really worked on from an ACM perspective is making sure that it is tightly integrated, and that you can just go ahead and call those things. Yeah,
that is, man, I cannot wait to see that. Like just like a full, complete in action workflow. I think that's going to be amazing. And then Christian asked, is this managed by Ansible on the back end, or like what's doing all the back end management?
So we're not using Ansible to drive this deployment. So what we essentially do here is we have an agent service. It's essentially the assisted installer agent service that gets injected into an ISO that we attach to these machines. Now, the agent service reports back into the ACM instance that we have here and receives its instructions. And so we've been able to drive down, okay, this is the configuration for the machine. It's able to report back all of the various different events and what's going on, right? So you can see here it's downloading the container image, and this will continue to increase as it writes the core OS disk image to the hard drive of the machine, and it'll continue to report in some of the updates. So this is reusing a lot of the work that we did through the assisted installer, and simply exposing that via ACM.
So what's the maximum? I don't know if you know this or not, but like what's the maximum number of nodes that you can have pulled?
I don't know off the top of my head, I'm afraid.
Okay.
Yeah.
Just this whole capability here, right? Like going back to like your slides earlier, right, about the remote workers and stuff like that. Like I was on a project where it was essentially clusters as a service, where we had the customer was saying, hey, I've got these developers that they're going to come on, and they're going to be at their own site. They're going to have their own account within AWS or Azure or GCP or whatever, and they're going to want to spin up their cluster that could be one or n amount of nodes. Man, it's so awesome. It's bittersweet, right? Because it was just like a timing fail, but right now it's like, man, this is the answer.
Yeah, absolutely. And you can see here, I mean, again, this is for those of you that know assisted installer, it chooses one of the nodes to be the bootstrap machine, right? Which is really cool because you don't need a separate one. You can start off with, I literally have one machine and I need you to provision OpenShift on that without any other machines being on there. And that's kind of where we're going from a true zero-touch provisioning model where I want to simply create an ISO, and I want to attach that ISO to a machine, and it has to bootstrap everything in place, and it has to do everything without the reliance on an external one. So this is sort of the first sort of incarnation of that. So we choose one node to be the bootstrap machine. It gets the cluster up and running, reboots, and it becomes a fully fledged cluster node. When you have three, like a non-single node OpenShift implementation, one of the machines becomes the bootstrap. The other two machines stand up a 2-node temporary cluster. And once that cluster has been established, the third node reboots and pivots and essentially joins that cluster. Yes. So again, you don't need that fourth bootstrap node like you do with an IPI install today, or even a UPI install today.
Man, this is so awesome.
This is coming along pretty quick, actually. So yeah, I still don't think that it's going to finish in the next 5 minutes, but
yeah, no worries. I was just reading the comment. So Pete Lauterbach made a comment, says, though the maximum nodes is interesting, the proper workflow is to bring up a basic cluster, then scale the cluster by adding the nodes that you need. Deploying a massive cluster is a Kate's anti-pattern. Yeah, I totally understand that, Pete. That it's just, if you've been on any customer call, like the one question, well, how many nodes can I have pulled at one time? So yeah, I get it. No, this is exciting, so yeah. Wow.
Yeah, it is really cool. And if you allow me to just carry on ranting away.
Yeah, go for it, please.
Another thing that we've been really working on is zero-touch provisioning for factory workflows. So the idea behind this is, well, we have customers, and it can be for lots of different use cases, but Edge is one of the big ones, where you might start off, you kind of want to provision your OpenShift infrastructure at the factory and then ship it to an Edge location or to your end customer and have it embedded inside of their environment. Well, traditionally OpenShift, I shouldn't really say OpenShift, more a Kubernetes thing, is when you want to change, IP addresses, cluster names, domain names that it knows about, it's just not something that's simply feasible to do.
Right.
And so the zero-touch provisioning for factory workflows is an implementation that basically allows you to provision clusters at the factory, get them ready to go within a kind of a base configuration from a networking perspective, ship it out to an edge location, and add in additional kind of doorways into the cluster and have it become sort of part of that edge location and the networking construct. So what I think would be a great follow-up topic is to maybe talk about some of the work that we're doing there and how organizations can deploy some of those clusters in a very similar way to what I showed you here, at the factory, and then ship them out and then do some slight reconfiguration when it gets set up at the edge location, very minimal, and it just becomes like it was almost installed there. So I think that's an interesting thing we need to do.
Yeah, I definitely agree. That sounds awesome, because we see that a lot too over I don't want to just single naps out, but we've had projects where a customer will be deploying high, right, or they'll build low, deploy high, and so that goes the same for their clusters as well, right? They'd want to build on the low side while it's connected because it's much easier, and then essentially unplug, move over to their air gap network, and plug in, and then be good to go. So I mean, this kind of fits right into that.
Exactly right. Exactly
that's
right.
Awesome.
Yeah. So this is pending user action, right? So this is actually really cool. What has happened here is the the process is expecting the host to boot from disk, but it booted the installation image. Now, this is a boot order problem with this virtual machine. In reality, this should never happen with a real bare metal host, because when this virtual machine was defined, we must have had CD-ROM as the highest one always, rather than So I'm not going to go. Yeah, I'm not going to go fix this now. But essentially, all I'd need to do is go in there, modify this virtual machine, swap it to boot from the hard drive, and things would continue. But it's just making it clear that, look, you've got your boot order wrong here, and it's booted up off the ISO again.
Yeah, it's saying this is a you problem, not a me problem.
Exactly right.
Right on, man. So is there we're kind of coming up at the top of the hour here.
Yeah.
Is there more that you want to kind of talk about, or I mean, because like this is super interesting, man. I could sit here and pick your brain all day. I mean, this is really what you showed today is some of the things that we've been kind of wishing for a long time.
Absolutely. I know we're right up against the time, although it just clicked over 5 o'clock here. So I think the only other thing that I would want to talk about and get people really interested in is Hypershift, right? So Hypershift is, how do I define it really, really quickly? You can essentially think of it about it in a way where you are divorcing the control plane from the data plane. So historically, when you think about an OpenShift cluster, and I think this is really important for those that are looking at, from a multi-tenancy perspective and lots of different clusters, is when you deploy a cluster, you are deploying 3 master nodes and however many worker nodes that you typically want inside of that environment. And typically all of those require individual nodes, right? You have your 3 master nodes and X number of worker nodes, but they all take up individual machines or virtual machines or instances on a public cloud. Now, perhaps from a bare metal perspective, if we think about it from that way, just to sort of simplify things, sometimes customers have said to us, well, I'm kind of wasting an entire physical machine from a master perspective. And you can kind of understand where they're coming from, right? Hypershift allows organizations to deploy what we call hosted control planes. Hosted control planes meaning, well, I'm going to put my control plane infrastructure, rather than deploying all of these as individual machines, deploy them as pods, as workloads on an existing cluster or distributed cluster. So every time you want to have additional clusters, you can simply spin up new control planes as workers, as pods, and you simply deploy worker pools. And that's where you would typically require a full machine or a full virtual machine or a full public cloud instance. So it has a number of different benefits. You can think of, well, being able to spin up new worker pools really, really quickly, not having to necessarily waste infrastructure. And I don't necessarily think it's always a waste, but for some customers, it's certainly a waste. And it also gives the ability to kind of guarantee that multi-tenancy. You're providing additional clusters for your consumers very, very quickly. So I know I'm over time.
You're good.
Yeah, I think it would be great to have a follow-up on Microshift. I can see that Peter Lauterbach is here. So we've been doing some work with Hypershift and OpenShift virtualization, right? So this is really cool where, let's say you have a bare metal cluster and you want to deploy lots of clusters on top, and you want to do that for developer needs an OpenShift cluster, right? You don't necessarily want to create them a project. No, you want them to have their whole own cluster. Well, with KubeVirt, we have the ability to integrate with Hypershift, we have the ability to integrate with KubeVirt. So you could deploy OpenShift clusters in OpenShift virtualization, where you're just spinning up virtual machines for your data plane, and your control plane is just pods on the underlying bare metal infrastructure. So you can happily give kube admin to those developers, knowing they've got their own cluster, they can do whatever they want with it, and you don't have to worry about creating these whole new infrastructure nodes and master nodes just for every end tenant. So there's a lot of power in doing that, and again, I think it's a great topic for another day.
Yeah, I love it, and Reese, you're more than welcome to come back. I mean, like this has been outstanding. I mean, just the amount of knowledge that you dropped on us today it's excellent. So,
Awesome. Well, I appreciate that, and the pleasure is all mine. Would be more than happy to come back.
yeah, awesome. And yeah, Christian. Oh, I'm sorry. Go ahead.
I was just going to say, I hope I've been an adequate stand-in for Sully, Christian. I hope you weren't left disappointed.
Well, hopefully I don't get fired after this since Andrew didn't make it, and they're like, oh God, please don't ever let this guy do it by himself again. But yeah, just for anybody that's listening to, we do have KCP on the agenda. We do have Hypershift on the agenda. So we're going to try and get somebody to come out here and talk about that stuff because we know it's interesting and it's definitely, we want to nerd out with them too and figure out like what we can do with it. And just hearing, just that workflow that you just talked about with Hypershift and OpenShift virtualization, that sounds pretty amazing.
Yep, really cool.
So yeah, so I know that it's late for you. So I'll give you a chance if you want any last words or anything like that, or if you're ready to go.
I don't think I have any last words. I'm really excited by some of the direction that we're going in here. I've worked for a long time on provisioning and virtualization and things like that. So we're really investing in some of these areas. I'm excited to see where it goes. So yeah, love to come back and continue to share where we're going and do some more demos of things that people are really interested in.
Yeah, nice. Yeah, thank you so much. And yeah, I'm definitely interested. I'm loving where we're going. This direction is amazing. It's like I said earlier, it's some of the stuff that we've been talking about for a long time, and to see it finally in action, it's amazing.
Yeah.
And somebody had made a comment earlier about Ansible not being part of the OpenShift Plus subscription. That is correct. The OpenShift Plus is really just like ACM, ACS, Quay, ODF, and OpenShift. Ansible Automation Platform is not part of that. There's a subscription guide that I'll paste a link to it. And one last note is we are setting up our GitHub repo with a blog and everything. So that way we'll give you a chance as the viewers to give ideas on what you'd like to see us, put on the show. So to have guys like Reese come out and talk about, just topics and stuff like that. So Reese, dude, seriously, thank you so much, man. This was awesome. Andrew, I can't wait for you to get back. This is nerve-wracking. I hope that your training is worth it because you sold me out. Maybe do this by myself. But no, I think this has been great. And yeah, we'll call it a day.
Awesome. Thanks so much. Cheers, folks.
Yeah. See ya.